it's finally the start of class. Hi, everybody. Welcome back to the Joy of Coding here at Portland State University. Thanks for coming back to the classroom. Thanks for joining remotely. We'll talk about what we're going to do tonight. First, we'll start off with what it's called Prime Minister's Questions. I just want to open up some Q&A, start off the class with anything that's on your mind. But then we'll spend the rest of our time tonight exploring the Java programming language. And we'll be doing it by not just like watching lectures or having me talk about the language. We'll work with Java code using something called the Java Koans, which give us an opportunity to learn about concepts, learn about and apply concepts in the Java programming language. We'll also work more with the GitHub repository that we created last week, and we'll be you'll see me use IntelliJ, my preferred IDE for the course. But first, let's start off with Q&A. What can I tell you? How have things been the last couple of days? More people's experiences like setting up the GitHub repository. Anything that you'd like to know here at the beginning of class? Yeah. Yes, I have. Yeah, I think I've gotten to everybody. So if you invited me to be a collaborator in your repository, if you haven't heard back from me, I think I'll get a reminder. But if you just want to ping me or something like that, I might have missed it. A lot of them sort of came in all at the same time, and maybe I wasn't paying attention too much. Maybe I had a lot to drink. I can't remember. Anyway, no. It was only like last night. I don't drink on Tuesdays anymore. Yeah, pandemic was rough for all of us. Cool. Yep. So there's that. Yep. Yeah. The GitHub lecture, you mean? You mean the introduction section? Oh yeah, Project Zero. Yes. Oh yeah. So yeah, right. So like all this stuff like brush up on your Java. Yeah, all of this is optional. Yeah. So yeah, Project Zero is not something. Actually, we will start working with Project Zero next week as an example of working with Java project to do test-driven development. So you can try it on your own if you want. But nope, it's not required. It even I think it says better say submittal is optional. Yeah. Right. Yeah. So you can submit it if you want. Actually, I don't know if you can or not. The submission program might not work with it. No one's done it in many years, so yeah, it's not a big deal. And then, yeah, these these old podcasts with terrible audio. Only if you really want to dive into the language and object-oriented programming. Honestly, I think the review, this stuff for tonight should give you everything you need. Just these are some older lecture notes I have that are just go deeper in depth. Although I guess, yeah, installing IntelliJ is kind of a required thing, well, or rather is a highly recommended thing, and we'll be seeing it tonight. On the class Slack, I propose starting class at 6 p.m. It looks like we'll be able to do that. The class before this one gets out at 5:40, so I think the room will be available. No one expressed any concerns, and if you don't, if you have concerns, please let me know either right now, it's fine, or via Slack. Otherwise, I say we'll do it. So I'll make a confirmation. I'll also reach out to the department just to make sure like there isn't anything that's happening here at 6 p.m. But I think that'll work out best for everybody. Cool. All right. Anything else that you want to know? Oh no, yeah, you're welcome. No, my pleasure. It's yeah, 6:40 is just too late, right? Sort of here for too long. And, yeah. Anyone who is remote, I'll open up the chat now. Any questions, concerns? Anybody encounter any issues, any big learnings that people had working with the with Git or GitHub? Okay, cool. So yep, good. Oh, so far so good. Thanks. Excellent. Good. Glad everybody is got it working. Hope it's pretty straightforward. That was the intent. That was not meant to be tricky at all. So okay, well let's dive. Sorry, any other questions before we dive into the looking at the Java language? Yeah. So and feel free to play along at home with all of this. Do it now or do it later. So the first assignment in this class, this isn't part of the six-phase project. This is this is a series. This is an assignment that I've used for several years now to help people get familiar with the Java programming language. A quick show of hands, how many of you have used Java at all before? Yeah, a little bit, right? Probably a couple weeks at the end of one of your 100 series courses or something. Good. Glad you've seen it. You probably remember some of the concepts about it. The fact that the language kind of looks like C, and that there's this whole, compilation through bytecode, the Java virtual machine, all that kind of stuff. That's cool. Whether or not you remember that, that's also cool. You probably didn't have a chance to dive too much into the language syntax or really some of the more nuanced aspects of it. And the Java Koans are a really good way to do that. So the word koan is borrowed from Buddhist discourse. And the idea, this is a teaching question. It's that kind of cliche or stereotype of what's the sound of one hand clapping, right? It's meant to be a teaching question to evoke a discourse between the student and the teacher to engender learning. That's what kind of high-minded. What these are a series of little pieces of Java code that are meant to teach you about a particular aspect of the language or an API or just how the language and the platform is used. Sometimes the answers can be subtle, but they're not going to be tricky, right? So this isn't a puzzle that you put together necessarily. It's really, sort of take it at face value and figure out, okay, you'll be asked, hey, you do something, and what's the expected value? And you're meant to, learn why it is or how how Java works. So to begin the course and to give you a good understanding and background in the language that we'll be using throughout the course, we'll work through a series of these Java koans so that we can learn about Java. This isn't my work. I've largely borrowed it from a guy named Matt Bentley. He lives in Chicago or something like that. I found this stuff on GitHub, and I've liked it a lot. And students have said that yes, there's actually quite a bit to it. There's a lot of little pieces to bite off, but it's given them the confidence and the knowledge they need to then be able to go into the projects and be able to focus on what the project's doing and not like the syntax of the Java programming language. So this will be the first Java project that we create in our GitHub repositories. So I'm going to walk through that process now. The first thing that we need to do, and actually I'm just going to open up a new terminal over here on the right. The terminal on the right will be PSU. So I'm going to SSH into the Linux boxes, one of the Linux machines. And I'm going to go to the checkout of the local clone of my GitHub repository that we created last time. All right, so as you'll recall, I'll just open this up in this tab here. So GitHub, not the Getting Started repository, but yeah, here we go, Joy of Coding, winter 2025. Right, we created this repository last time from the template project, and this is what you all did. After creating it, we ran the survey script, which asked you some questions about yourself and created that me.xml file. That file is used by the create project scripts to configure things and sort of know who you are and things like that. So we'll come back to this a little bit later. But right now, what we're going to do is use this create koans project script to do exactly that. So here I am on the PSU machines. I run create koans project. And what this does is this uses something called a Maven archetype to create a new Java project for the koans here in my checkout my GitHub repository. The script and the archetype just save you a bunch of steps. I mean, we're only in the second class, and in order to get this far, you have to learn about Maven. You have to learn about how to create projects, everything like that. I started out doing that, and it wasn't effective because it was students were getting tripped up. It was just too much for the second day, and so then instead I wrote the script to do it. So when I run the script, it goes and creates it. Now, when you run the script, you'll probably see that it downloads a whole bunch of stuff from the internet. You'll see lots of stuff scroll by. That's all of the dependent libraries of the project, and lots of things about a Maven too, perhaps. I've done that. It's all cached locally, so I guess we didn't see it go by here. But anyway, so now I'm going to run the git status command. So you can people see that okay? Let me know if you can't. And this tells me what has changed in my GitHub repository. So it tells me that a file called pom.xml has been modified and that there is an untracked file in the koans directory. So pom.xml is basically the Maven project configuration file. There is a Maven lecture. It's probably like, I don't know, session 8 or something like that. So it's not something that you need to know about now, but I think what you do need to know now is that pom.xml is a Maven project. Yeah. Git status or the create koans? Nope, I didn't. That's good. Yep. Yep. I created the koans project here, and so now I want to add it to my GitHub repository. This contains the source code for the koans. So I'm going to say git add koans directory, and now when I do a git status, it shows that there are a whole bunch of files that were added. So these are yeah, there's some like files to run Maven and everything like that. But then there's all these Java files, which we'll be exploring tonight. This is the source code that contains all of the koans. These are the files that you'll be working with in this project. And so I'm also going to add the changes to my modified pom.xml to the changes to be staged, to be committed. And now I'm going to commit them to my repository. So I'm going to say added koans files. And I'm going to push that up to GitHub. Nice. Okay, so that pushed it. And so now if I go back to my repository here in GitHub and I refresh, oh, sure enough, and the latest commit was just now, and that I added the koans files. Good, so everything got pushed up to GitHub. So that's the first step that you need to do. You need to go onto the PSU machines, run the create script. By the way, the create project scripts only run on the PSU machines. It just keeps it simpler that way. So simpler for me. That way I don't need to like worry about having scripts that'll run on whatever operating system that you're running on. Create the project, commit the source code, add and commit the source code to your GitHub repository. Now, for this course, you can develop on whatever machine that you like. Really using whatever tools, whatever IDE or text editor that you like. So, I mean, if you want to use this course as an opportunity to get better at VI or Emacs or whatever it is that you want to use on Linux machines, sure, go for it. It'll all work. It'll probably take you a little bit longer. You'll be missing out on some of the refactoring and navigation tools that we'll see in IntelliJ, but you can do it. And actually, what I'm going to show you now is how to run the koans project. So we created the code, and then we're going to go into that koans directory that was created, and we're going to run the command. Actually, I'll minimize this window so we can see this Maven W command. Now, Maven W stands for Maven Wrapper. So Maven is a tool that builds Java projects. Actually, Maven itself is written in Java. So okay. And the Maven W is the Maven wrapper script that will not only run Maven, but also download Maven to your local machine to run it. This way, you don't have to like install it yourself. It just saves a step. So I'm going to run Maven W, and I'm going to say exec Java. And what this does is it runs a main method of a Java program. And what that what that Java program does is executes the koans. So what it displays here is a little message saying, like, you need to go do something with one of the koans. And we'll see, once you see the code, I think this will make more sense. But the whole idea is that you've got 268 of these things to do. And like I said, they're little bites, but it'll probably take you a goodly amount of time between now and when it's due in 2 weeks to get through all of these. I do encourage you to take your time and go at a reasonably brisk pace so that yes, you can get them all done, but that you actually can learn what you need to learn along the way. But by running the command here on the PS2 machines, I just want to make sure that everything works. It looks like it is. It's telling me you've got some work to do. That's great. So I don't want to do, I'm going to hit Q to exit. I don't want to do my work on the PSU machines. VI will do in a pinch. I'll use Emacs when I'm feeling lazy or just need to do something quick. But what I really want to work on is my local machine on my laptop in my development environment that I prefer. So I'm going to, but first what I need to do is I need to get the source code on my local machine. So I'm going to go back to, I'm going to go back to this terminal right here. So this is running on my local machine. You can tell it's David's MacBook Pro, and this thing over here is the Rita machine from the CS department. And I'm going to make a checkout, a clone of my repository, of my Joy of Coding Winter 2025 repository. So I'm going to copy the URL here. I'm going to make a clone on my development laptop. And now, yep, I've got the directory. And here's all the files that are there, including the me.xml that I created last week, and including my koans. Good. So now I've got all the source code here. And I'm going to run that Maven command again. That was, let me just make sure I got that right. It was exec Java. Yep, Maven w exec Java. And this will build the project and run that main program. Oh yeah, it's downloading some stuff. Oh, file not found exception. Wasn't that interesting? Did I not commit everything? Oh, I did not. Thank you. Good. Run that again. Oh, I wonder why I found that. Probably because it went into the subdirectory. Or Maven did, but it wasn't in the right place. Nice. Okay, great. Here we are. So this is telling me that I need to do something about the cones. It's actually telling me that there's a file called aboutkoans.java that I need to go look at. It's telling me line 11 is problematic, that there's ponder what's going wrong in the about koans class's find about koans file method. Okay. So I need to do something, and I want to do something not here in like the command line environment. I want to do something in IntelliJ instead. So I've already downloaded and installed IntelliJ. It's just like any other program, on my Mac, I download the DMG and I run it and it all installs and everything. So I'm just going to run it here, IntelliJ idea. There it is. And so then, oh, looks like my version's a little old. Sorry, I haven't updated in a while, but it pretty much all works the same. So when you open up, let's see, geez, how many of you have used an IDE like VS Code or IntelliJ or PyCharm or something like that? Okay, pretty much everybody. So, okay, these concepts should be familiar to you, so I'll go a little bit faster. So I'm not going to explain what an IDE is. I'll highlight how to use IntelliJ. So when you start up, it's asking you like, hey, what project should it run? So IntelliJ has a notion of a project, of a code base that you work in. And what we're going to do is open up the, basically, the code base that's there in your GitHub repository. It's there in the checkout. So I'm going to do that by clicking Open. And this let me browse the file system for, where's my PSU? PSU Git, David Whitlock, Joy of Coding, Winter 2025. And there's a little bit of nuance here. You want to open the pom.xml file. So actually, this is really important. Sometimes people will open up the directory. IntelliJ doesn't always get it right. But I found if you open up the pom.xml file, IntelliJ will recognize that, oh, look, this is a Maven project, and will analyze everything for you and configure itself for that Maven project. So I'm going to do that now. It'll say, pom.xml is a project file. Would you like to open the project? And say, yes, open as a project, not open as a file. So open it as a project. And so then IntelliJ starts doing its thing. It'll analyze the project. It will figure out all of its dependencies. It'll download third-party libraries that it uses. That's a nice thing about Maven. The pom.xml describes everything that it needs. And now it's loading it. It detected some things about Maven and the Maven wrapper. And now I'm able to edit the code in my for my project here in IntelliJ. Now, I've been using IntelliJ for a long, long time. I've upgraded through a number of versions, and what I found is that it's kept some of my customizations over the years. So my IntelliJ will probably look a little different from yours. First of all, I have old eyes. I prefer light mode, and so then mine's in light mode. You all with like your healthy eyes probably enjoy dark mode better. Great, go for it. I don't. I can't read blue on a black background. I don't know how you all do it. It's like see a link. It's like there's something there. But anyway, so I like the high contrast. And over here on the left, so I've got it configured, and maybe yours are the same. Over here on the left is a navigation pane, and you can configure exactly how things are structured. I like the project structure myself, and so then this basically arranges the code for the project, which is the code that's in my repository, right? So if you look at the checkout here, I'm going to quit out of this. I've got if I go to the top level, I've got things like my creation scripts or README, the koans directory, the source directory, things like that. And I've got the same thing here, right? There's my koans directory. There's my create scripts, got some hidden files like .github and .maven. It's all represented right here. Now, the koans directory is actually a sub-project of the top-level project. What we'll do over the course is, like next week when we learn about Project 1, we'll create a new sub-project that's a sibling project of koans for Project 1. I'm getting ahead of myself. Anything that's got like this, that's in bold and has like this particular little icon that says it's a module, that's a sub-project. And you can open that up and navigate through it. So it's got its own Maven file and stuff, so you can run it there. But it's also got a source directory. And so by looking at the source directory, you can see that there are a number of packages, Java code packages in there. And let's see here. If I go back and I run the koans again, it says actually it tells you the location of the actually in the wrong directory. They'll tell you. Yep, that you are looking for in the koans directory source beginner about koans.java. So let's see here, source beginner. There's a whole bunch of them about koans. And when I double click on that, it opens it up here in the editor. So this is Java source code right here. Now, hopefully it looks a little bit familiar. You've got things like a package declaration up top. Actually, move that up a little bit. Package declaration up top. It's got some import statements saying that it uses other classes like these, like the koan annotation here, which is imported by this com.sandwich koan. That's the code that Matty B guy wrote, Matt Bentley wrote. And then it's got a couple of these methods, but this is just Java code, right? So it's a class and it's got some methods in it, and this is what we're working with. So if we go back and look at what it's telling me, it's saying how there's something wrong about the find about koans method. Okay, so find about koans file method. Now, this is how you do a koan. You look for a method that's annotated with this @koan, and the command line program told you that something was wrong with it. And so it's what does this method do? Well, it calls this fail method with the string delete this line to advance. So what do you think we need to do here? Yeah, comment out or delete the line. Well, it tells me to delete it, so I'll just delete it. Let's go ahead and delete it. Now I'll go back to the command line. IntelliJ will automatically save that change when it loses keyboard focus. The command line program detected that change, and it's displaying some different output. And most importantly, it's told me I've done 1 out of the 268 koans. Hey, I've made some progress. Okay, now it's telling me a koan is considered complete when it no longer throws an exception. Often there's more than one way to solve a koan, but only one correct way. This is often hinted at within the koan itself, or the comments appearing here. Okay, now it has a standard boilerplate. Ponder what's going wrong in the About Koans class definition of koan completion, which is spelled correctly, method. Line 17 may offer a clue as how to progress. Okay, so let's see here. It was saying line 17. So line 17 is the line that it fails on. So let's look at this code. Let's see here. It declares a variable of type Boolean with a value of false, and it says if not koan is complete, then fail. Well, right now it is certainly failing because not a value of false will execute this branch. What do you think we need to do to make the koan pass? Yeah, change koans is complete to true. I hit TR, and IntelliJ knows to suggest something like, hey, did you mean true? I said yes, great. I hit tab, and then it completes it to true. Oh, and by the way, you probably noticed that down here at the bottom of my screen, I have some green messages popping up. I have well, actually, it used to be a plugin. I think now it just comes with the IDE. But whenever I use a keyboard shortcut, it pops up in the description of the keyboard shortcut, so you can also see what keyboard shortcuts I'm using. I tend to use the keyboard shortcuts a lot because it helps my fingers go as fast as my brain and maybe my mouth. And so then, but if you ever want me to do something again, if you missed it or want me to slow down, please let me know. Okay, I made this change to true. I changed the code. And now when I go back, it reloads. Good, I've got 2 out of 268 done. Awesome. And now it's telling me that there's something going on in the About Assertions class. Okay, that's a different class than this one. So I guess I'm done here, right? I have made both the koans pass. Okay, so sort of see what we're doing here generally. Okay, let's move on. You got a big smile on your face, like, what? Yeah, okay, good. Yeah, exactly. It's like these nice bite-sized pieces. You get immediate feedback, right? It's a good way to learn. Okay, that was about koans. Next, it's about assertions. Okay, let's find about assertions. Now, I can find about assertions, really easily just by looking here on the left because I got the navigation open. But there's another way that you can use IntelliJ to find different classes. And again, I'm looking for about assertions. If you go to the navigate menu, and you can say navigate to a class or Command O on my machine, and then you just type in the name of the class. So about assertions, great, and it finds it, and you can just hit return to go to it. So I'm going to try to show you how you can use IntelliJ to navigate a code base quickly. Okay. Now, assertions are statements, but you see them in the koans, and when we talk next week about writing unit tests, you'll see that the JUnit framework and Hamcrest have assertions also. Assertions are statements that check the validity of some information. They basically assert that a value is true or that 2 values are equal. And when they aren't equal, or something that that you expected to be true was false, when an expectation isn't met, it fails, right? To tell you, to give you feedback. So if we look at what the I'm going to minimize that for the time being. If we look what this is saying, is it tells you that the following. The 2 underbars are an attempt to communicate the need to fill in an answer. Judging by context, what should underbar be replaced with? So again, ponder what's going wrong in the about assertions class, assert Boolean true. Line 13 may offer a clue as to how to make progress. Not my case. What went wrong? So I expected something other than underbar, but was underbar. And sure enough, here on line 13, it says, okay, assert true of some value. And it's kind of like fill in the blank. So like underbar is just actually some like string or something like that. I don't know what it is. But it's expecting a value of true. Right now it's got underbar. What should be there instead? Yeah, true. Okay, so now I'm going to assert that true is true. Run it. That was 2. Great. Now I'm at number 3, line 18. Now it's assert Boolean false. Okay. So we want to assert that a particular value is false instead of the, I don't know, value. What should this be? False. Okay, good. I think you're getting the hang of it. Okay. Let's just go through a couple more and see how they do. Okay. And by the way, I mean, this is meant to not only teach you about like what these assert methods do, because you'll see these in all the koans, but also, you're starting to learn more about Boolean values in Java, right? So, in C and C++, well, or at least C, there isn't a built-in Boolean type. Instead, you sort of use, 0 is false and anything non-zero is true. That's an interesting convention, but it's not necessarily type safe, and adding numbers to Booleans, I don't know, it just adds a little bit of cognitive overhead. And so the designers of the Java language said, well, let's have a built-in Boolean type. And so then you've got these keywords, true and false, that mean that. Okay, here's the next one, assert null object. So a reference to an object can be null, which is it's a keyword, I don't know if it's magic or not, which means that there's nothing there. So right now, this one is failing because it is, again, assert null. It was expecting something other than underbar, but was 2 underbars. What should this be? Null, right? There's a keyword null in the Java language. Okay, let's move on. Assert null object reference. So here I've got a variable of type objects. Now an object just can mean anything in Java, right? All classes descend from Java lang object. You'll learn about that in the lecture content in the Java review. And we want to assert that the value of that variable is null. So what should we fill in the blank here with? Null, right? Yep. Okay, here's one, assert not null. Right now it is null, and actually, so then if we run this, oh, this is nice. The message is a little different now. It's saying expected something other than null, but was null. Well, so then what should we put here? So null isn't the right answer here. We want something that's not null. Oh, 2 underbars. Oh, that's an interesting one. Wonder what's going to happen there. Actually, did that work? It did. That's not the answer I would expect, but it worked, so that's cool. Are there other ideas that people have for what a non-null object might be? True or false? Okay, I wonder if that's going to work. What? Sorry? Okay, well, let's see if that works. So does 37 still pass? Yes, it does, because it's complaining about line 42. Like the number 1, okay. Yep. Yep, 42 still, it's happy there. The string hello, right, okay, right. And this is what you can do with these codes. You can sort of, experiment and figure out, hey, what are the things that work? Okay, here's the next one on line 42. Assert equals using expression. So we want to say that the value of this expression, hello world, equals something. So right now this is failing because this is fill in the blank. So what should we fill in the blank in here with? Sorry? Hello world, okay? Nice. Oh, sorry, what? Let's see here, line 42, expected true but was false. I have to capitalize W in world. And add an exclamation point. Now, so you just learned some things, right? You learned that, well, I guess that equals, expects exactly the same, and that, yes, it's case sensitive, things like that. Let's see here, that one passed, right? Because we're on 42 now, we're on 47. Now, I'm looking at IntelliJ here, and I noticed that IntelliJ highlighted this dot equals call in yellow, and I'm curious about that, so I'm going to hover over it. And what is it saying? It's saying equals is called on itself. Okay, well, that is true. It says equals, yep, equals, the equals method is always the left hand, well, the argument passed to the equals method is the same as the string that I was called on. And IntelliJ is telling us, like, this is probably not something you want to do, right? Because this expression is always going to be true. Now, here in the koan, it's what's intended. But, IntelliJ doesn't know that. If you do this in other code, in your project code, it's probably a smell. It's probably an indication that is not what you wanted. Whenever and so this is the kind of thing that IDE will help you with. It will give you insight into the code that you wrote to figure out, is it, are there sort of well-known problems with it? Nice. Okay. Moving on to our next koan, this is using the assert equals method. So what do you think assert equals does? Yeah, right. It has two arguments, and it asserts and makes sure that where we pass in there are the same. So let's just see if we can go through these pretty quickly. So what should hello world be equal to? Hello world, with a capital W and an exclamation point. Assert that the number 1 equals 1. 2 plus 2 is 2 times 3 is 3 minus 8 is minus 5, and so that's the syntax for negative numbers. And then integer 10 divided by integer 2 is 5. So that should be okay. So let's see if we got all those correct. Oh, I think we did. Yes. Okay. Here's another variation of assert equals. So the assert equals up here took 2 arguments. This one takes 3 arguments, and the first argument is sort of an explanation of why of that something went wrong. So here, and that explanation is included in the error that's printed there. So it says the answer to life of the universe and everything should be 42. So it expected something other than underbar, but was underbar. So this underbar should be replaced with 42. Okay, so the whole idea here is that this particular koan is teaching you all about these assert equals and assert true methods that you'll be seeing throughout all the other ones. Okay, now assert same instance. This is using, assert equals, but also, assert same. So let's figure out what these are. So let's look at this code. Let's see here. It has an integer called original that has a value of, new integer 1. IntelliJ is telling me that this particular constructor of the class Java-lang integer is deprecated and marked for removal. Good to know. So what deprecated means is that this is an API that was introduced at one point, and now the maintainers of the API are saying, I don't think we want that one anymore. I won't go into the details about why this was deprecated. You can look it up. But this is sort of a warning. It's like, maybe you don't want to use this, or maybe there's a better API to use. As a matter of fact, I think what we can actually, if I do, can I do a context action? Okay, so IntelliJ has these things called context actions, which allow you, which will fix your code for you, basically. So like if you, type something that has a bug in it, or if you, we'll see lots of them through the course. Like if you go to start, importing a method or something like that, it'll complete it for you. Sometimes it'll fix problems. This one just tells you that what the inspection was. So there's nothing really to do here, but I bet if I change this to just 1, it's happier now. So I don't know. You don't have to do this, but I'm curious. So that seemed to work okay. So let's see here. So the variable original has the value of 1, same has the value of original, and then different has the value of 1. Oh, this isn't going to work though. I don't think. Is it going to work? No, it's not going to work. This has a very specific. Actually, we can try it afterwards. So we'll come back to that. So original is a new integer 1. Different is a new integer 1. We have the assert equals, and I think, let's see here. I'm going to go back and look. The error was on line 72. So both of those passed. So original and same and original and different are equal. But assert same does something else. So remember up here, and you'll learn about this more in the lecture, we call this dot equals method. So, uh, so does anybody know what the equals method does? Yeah. Ah, okay, right. So yes, you mentioned, is it the value or is the reference? So the equals method, its semantics is that it's an instance method, meaning that an object, has that method. You can invoke the method on the object, and the behavior of the method, the semantics of the method, is to say, hey, am I logically equal to this other object that's passed in? So yeah, it's not exactly a value comparison. I think it was a logical comparison because maybe the values are different. But the whole idea is like, hey, am I equal to that other method? And as we'll learn about in a couple of weeks, this is used all over the place. The collection class is a very important thing in Java. Sorry, did you have a question? Sorry? Yeah. Ah, good point. So the question was, yeah, is it equal, but also has to be, is it also the same type? It doesn't have to be. The way the API is written, as a matter of fact, we can drill into the API by actually, sorry, let me go to this. Go to uh, declaration or usages. Here I'm looking at the implementation of the equals method on the string class. So this is like a Java class. Here's like the source code for the JDK. And if you look at the signature for this method, it takes any old object. So it doesn't have to be the same type. You could, string could implement the semantics of, sure, I'll compare myself to another string, or I can say I can compare myself to an integer. Sure, if I represent the string, double quote, one, double quote, I could be equal to the integer one. The Java API doesn't put any constraint on that. Now, in practicality, it would make kind of an interesting type system if objects of drastically different types could compare each other. So comparing an integer to a socket, that would be weird, but I suppose you could do it. I don't know if it would be very useful or not, right? So yeah, almost always you'll see an implementation like this. The first thing it says like, hey, listen, actually, and look, the first thing that this equals method does is say, hey, if we are the same object, so here if you're using the equals operator, this will compare two objects for object identity. And actually, this will get back to what the koan's doing here in a moment. So if this object, if the object on which the equals method is invoked is the same as the other one, as a quick, nice shortcut, yep, we're definitely equal. Otherwise, what does it do? Well, the first thing it does is, okay, this is kind of a weirdo implementation, but it checks to make sure that the object is an instance of the string, and if it is, then it does some more advanced comparison because of strings. We won't dive into those details now, but that's what equals methods do. They basically say, hey, am I logically equal to this other object that was passed in? And almost always the first check is, well, maybe the first check is object equality by using equals, but then you say, hey, listen, is that other object of the same type? Great, now I know how to compare it using, comparing my fields to its fields. So that's the dot equals method. We were looking, and that's why original and same are equal to each other. They both represent logically the number one. Assert same will use that equals operator. So what is the same object as original? Same is yes. Very nice. So we'll put same in here. And now it was filling on 72. Yep, now it's on 84. Right, but note that if I was to replace same with different, oops, it would fail again. And look at the error, right? It said, oh, I expected one, but was one. Oh, that's kind of crazy. And that's because what this assert same is doing, I'll drill into the implementation here. Not refactor. Go to. See, I don't know the menus, but I know the. Oops. Go to declarations. Oh, I don't have code here. Download sources. Here we go. It has two objects. If they are not the same, then fail with that they are not the same instance. These are different objects, right? So you create one object here and you create another object there. They are equal logically, but they are not the same object. So here, and that's why this fails. Now, the way that what happens is that it prints out the string value of the objects. They both have the same string value. So it makes it a little confusing. So here it's just sort of a display thing, right? They display the same, but they are not the same object. Cool. Okay. Now I want to try a little experiment, though. I'm really curious. And this is, this is what I like to do with the koans. Is sort of like play around with it. So, like, what if I just change this to the number 1? Okay, it was failing on 72. Ooh, that passed. So now it's failing on 84. So isn't that interesting? So that when, instead of creating a new integer object, if I just use a reference to the constant 1, these end up being the same object. So not only are they equal, but they're the same. This really isn't in the spirit of the koan, so I'm going to undo that. But it is a little interesting thing you can play around with. Yeah, your question. Oh, nice. New integer. Okay. And now didn't for me. No, well, it might be a difference in the version of Java that you're using too. Well, that's wild. I'm kind of surprised, but maybe not. So, right, this is the thing, play around with it. Okay, I'll do a little sidebar here. But like, it might be that it might be that the compiler, actually, which version of Java are you using? I'm really curious about that. So you can do that by saying java-version. Oh, I'm using Java version 17. That's kind of old. Do I have? Why don't I have a new version of Java? I don't know. 21. I wonder if something changed between the versions of Java. So for instance, there might be an optimization they put into place, is that the compiler says, oh, look, if I create a new integer 1, because this object is immutable, it's never going to change. It's always going to represent 1. You can't change an integer. It might just replace it with the constant for integer 1. And logically, it's all the same, but look, yeah, here's a place where it doesn't work. So boy, I'm super curious. I thought I had Java 21 on here. Oh, maybe something didn't build right. That's why I changed it. Oh yeah, Java 22. So I wonder. Oops. I'm just gonna. Now I'm running 22. Now if I run the koans again, let's complain about 72 again. Okay, so don't know. Stranger things have happened. And actually, that's probably going to use Java. It ought to use. Let me just make sorry. Yeah, okay. Don't know. Yeah, stranger things have happened. I'm going to go back to Java 17. How did I need Java 17? I don't remember. Anyway. So look myself a note. But yeah, so again, the whole idea is that you can play around with these things, and oops. and explore the language. Learn about the language by experimenting and not just reading about it, not just oh, what's the stuff happened here? Do it twice. Okay, there. So anyway, let's continue on a little bit more here. Okay, not same instance. Okay, so here we have sort of the same thing again, but we asserted that same and different are same is equal to the original. Different is equal to the original, but only one of them is a different instance. What should we do? And actually, oh yeah, here's another like expected the same instance. Expected 1 but was 1 instead. This should be, we're asserting not same. Yeah, that'd be different. Nice. Okay, and so now, oh wait. Oh, thank you. That's why it was, there we go. Yay, good. Now we're on to a new one. It's told me that I'm now passing about koans and about assertions. The next one is about equality that I'm on. But I want to, I'm at a good stopping point. I've got stuff working. And so what I want to do is I want to commit these changes. So, okay, I don't know, I'm of the commit early and often. And by commit, I mean commit to the Git repo. Early and often. So now I can go back to my command line and I can do git status, and it'll tell me that I changed my about assertions class and my about koans class. That's nice. You can do all this stuff in the command line. But I like to use IntelliJ to do my git stuff. So I can go over to the commit section here, and if you're using like the new stuff, there are all these. It's all down here now, and there aren't any words anymore. They're just icons. I'm sure this works for somebody. It doesn't work for me. I like the old school way of doing it a lot. But what the commit I don't know, not menu, commit dialog, I don't even want to call this thing, commit section does, is it tells me what's changed. So IntelliJ has really great integration with GitHub. And when you see files that are blue here, so like my README is just plain on black, something's been modified. If you see something that's blue, it means it's been modified. And so then, and you can also see what code has been modified by what's here in the margin. So if you have this blue bar in the margin, it means the code has been modified. If you click on the blue bar, it'll tell you the old version, or rather the current version of the code, the unmodified version of the code. So you can just figure out what you've changed. You can do things like you can roll back. You can get a bigger diff by doing this. And by the way, it's the kind of thing that you do a lot when you're writing code real. It's like, oh yeah, I made a change there. What did it used to be? Right? Oh, it looks like it broke something. What did it used to be? And so then you can navigate modified code that way. Over here on the left again, I want to commit these changes. So I will select them for committal, and I'll say here in this part of the dialog, I type in my message. This is the same thing as doing git commit -m. Implemented the first two koans. And you can commit, it'll just commit to the local repository, or you can do a commit and push. Now, like I said, my IntelliJ has been committed forever. Has been configured forever. And so everything just sort of works for me. I got to do it twice because I found some warnings. You might find that you have to authenticate with GitHub the first time you go to push. But it's telling me, well, it's already committed. Yeah, it's telling me sort of here's what you're about to push to GitHub. Yes, that's what I want to do. And so let's see, here's push, or I don't want to force push. It'll push it up there. And now if I go back to GitHub, I'll reload. And it said, yep, implemented the first two koans. Very nice. And now I want to go back to my PSU machine. Right here. Yep, I'm still running on PSU. And sorry, I'll get my little bubble out of the way here. And now if I do a git pull, right, this will pull the changes from GitHub into my local checkout. And it said that, yeah, look, you've got two files that were modified, the two that I modified, about assertions about koans. That's cool. And now when I run my koans again, oh, good. I see that's in exactly the same place. I've got 12 out of 268. So both my local machine and the PSU machine are in sync. Everything's working the same way, which is really good. Okay, and I think we're a good stopping point. Want to take a break? Actually, any questions? Oh, darn, I gave it away. Yeah. We move by wait to continue. Oh, well, okay. So the koans are due. Actually, yeah. Let's conclude with that. So, um, let's see here. Yeah, I'll show you the submit script after the break. But this is due in 2 weeks, January 22nd. So you got to have all 268 cones, whatever it is, done by then. As you can see, they go pretty quickly. Now there are some that are a little bit more challenging, and there are a lot of them. So all of the advice has been, that I've gotten from the students is like, yeah, start on them early. Just do a few every day, start getting into the zone, and do stuff, but go at a good clip, but not so fast that you're just that you're not learning anything. So yeah, so this is the first project, the first assignment in the course, and it's meant to sort of give you that foundation in Java. Thanks. Okay. Let's take a break. Take a 10-minute break. When we get back, I'll show you how to submit projects in the course, and then we'll do some more koans. Yeah, that's probably it. Okay, hey. Well, welcome back. Okay, so in the first part of the course, we broke ground on the koans project. So we created the Maven project on the PSU machines. We checked everything into GitHub, got a checkout on our local machine, opened it up in IntelliJ, and started going through it. Right, and as we saw, the koans are all about these little pieces of Java code that are meant to teach you something about the language. And we went through and we solved two out of the koans. When we run it, we get like 12 out of the 268 that are all working. And this is how you do it, right? You go through and you just do these things a little bit at a time. And then we committed the changes back to Git, pushed it up to GitHub, got those changes on the PSU machine, ran it to make sure that it behaved the same. And that's kind of the workflow that you have, right? You'll implement some koans, you'll get to a safe point, you'll commit some stuff, and eventually, though, before you submit, you want to make sure that they run on the PSU machines. And so that's what you can do here. Now, speaking of submitting, I want to talk about how to submit code for this course because that's how you give me the code to grade. And the submit procedure is here. You go here in the README of the repository. How do I submit my projects? So, as I mentioned last time, I've automated a lot of things in this course for two reasons. Primarily, it's for my own benefit. There are a lot of you. There's only one of me. I'm lucky to have two graders. I don't always have two graders. So I want everybody to be able to focus on the things that are most important. I want me to be able to focus on answering your questions and the questions that matter. I want the graders to be able to focus on providing you feedback as rapidly as possible on the things that matter, like the quality of your code and how it behaves. I mean, I want you to be able to focus on writing code and working with the tools and not fighting things like system configuration or like running a big long Maven command on your first day where you might have cut and paste errors and things like that. I've learned all those lessons the hard way, so I've tried to automate those things to take the toil out of getting started with the course games and the toil out of having to respond to a lot of little one-off questions because everybody's got a different environment, or the toil that the graders would face when they get projects that aren't easy for them to grade. One of the things that I have automated is the process of submitting the code. I don't know how your other program-intensive courses, send your code to the people that grade it. But one of the things that actually, I'm pretty sure I did this in like the first time I ever taught, was I wrote a program that will take the source code, put it in a zip file, and email that zip file off to the grader account for grading. That program has been around forever, and recently I've added a submit script that just streamlines the whole process and makes it super easy. The submit program is like the submit script, just like the create scripts, can only be run on the PSU Linux machines, and it does a couple of things. So first of all, it runs it builds the project end-to-end lifecycle, and I'll talk more about that later. But the whole idea is that that gives you an opportunity, one last opportunity, to make sure that your code works as you expect on the PSU machines before it's graded. Please make sure that your code compiles. If you submit code that doesn't compile, you'll get a nasty gram back from the grader. Actually, you'll get a nasty gram back from me, because I'm the one that runs the submitted code through the scripts, and I always take a pass over everything just to make sure that everything compiles. I don't want the grader to waste their time to have to look at, like, a compilation error and then have to send you an email. I'll do that myself. Basically, don't create more work for the grader. There's only 2 of them. They've got a lot of stuff to do, so make their lives easy. Also, a couple of notes here. Please, for your code, this won't be the case for the koans, but it will be for the projects. If you add some debugging output or print lines or whatever like that, please remove them from the code. The grader, again, I want them to be able to go really fast so they can scale to so many of you. If they have to go through pages and pages of of debugging output, you're going to lose some credit for that. So here's how the submit script works. Basically, it takes one argument, which is the name of the project to submit. So here in the assignment, I hope I call out. Oh, actually, I don't call it out. The way you submit it is that here from the top level of the checkout, you run the submit script. By the way, I always prefix my shell scripts with ./, which means so in Unix, the path environment variable is the if I look at my path. Sorry, if I look at my path, it's got all these different directories on it, separated by colons. These are all the places that it'll look for executables. But you'll notice that, well, actually, I guess in mine, dot is on the path, but a lot of people don't have dot on the path by default. So I always prefix my scripts with ./ to basically say, run the submit.sh script that is in the current directory. So you run submit.sh, and then you give it the name of the project. Actually, if you run it with nothing, okay, it says you must specify a project name, but it doesn't give you the options. It's koans, so you say submit.sh koans, and this will run the submit script. This goes off and it builds the project, and it's going off, and so the output kind of goes by kind of fast, but it did go off and say, hey, listen, you've only done 12 out of 268. I would recommend against submitting this. Please do some more, but this is the way it is right now. And then it prints out, here are all of the files that are being submitted, just so that you can make sure that it's got everything. And then it asks you an important but ultimately optional question. So, I taught the course for a number of years, and then early on in one offering, a student asked, well, about how long should I expect this project to take? And I'm like, well, I don't know. I've never done the project myself, and I'm sure I would do it much faster than you. And so it's like, well, this is a quandary, but it's a very important piece of information. And so then I'm like, well, I could always ask. And so I modified the submit program to ask you how many hours you spent on it. And actually, if we go back to the README here, I've gathered that data and I've summarized it. Here. So over the years, if you look at the Koans project, and so I don't know, starting in the summer of 2022, and so there's probably been 4 or 5 offerings of the course since then. I've had 97 students submit the Koans project. On average, it took 20 hours to do it. And then I also have, a whisker diagram of sorts. So, the maximum anyone ever reported doing it was 100 hours. Okay. The minimum, someone said they got done in 4 hours. I kind of doubt it somehow, but whatever. But I think the top 25 and bottom 25 and the median are probably more interesting. So the median is 16 hours, which means that half of those students took more than 16 hours, half of them took less. The top 25 basically means that 75% of the students took at least 24 hours, but 25 took more than 24 hours. So as you can see, there's kind of a disparity between the top 25 and the maximum. But anyway, I don't know if this is useful or not, but it sort of gives you a rough idea. The goal isn't to like try to figure out where you sit here. The goal is to like give reasonable, accurate information to inform other students in the future. Yeah. I don't know if you get extra credit for it, but yeah, or you can use a stopwatch. Yeah. Uh, or however many empty cans of beer you got, or whatever. Yeah, whatever, however you want to measure it. Yeah. Yeah. Um, yes, it's. But here again, it's. Yeah, I mean, I guess you could also. I don't know if there's a way to look like your Git history or something, so tell you like how long you've taken things. Or I don't. There might be an IntelliJ plugin actually that might. Go figure it out. I don't know. Yeah. But anyway, I collect this data for your information. I don't know how actionable it is. I don't know. Your mileage may vary, but it does give you, an idea of sort of, what to plan, and then also, um, again, over the years, you know, only 25% of the students reported they took less than 10 hours. So, okay. So here again, yeah, sort of plan. It's like, 16, 20 hours, to do these koans. And given that there are like 268 of them, it seems reasonable to me. But I probably would not have guessed that. I'm glad that we have data to inform it. And I've got information here for all of the projects. Anyway, the submit program will ask you how many hours you spent. So I'll say, hey, I spent 8 hours working on it. Sure. Actually, I spent like 1, but anyway. And then, it's like, hey, do you want to continue? Yes, I'll do that. And then it goes and creates that zip file, emails it off to the grader, emails you a receipt. Oh, and it does something else also. The submit program, I'll go back up here. Oh, yeah, there's some more information about what can and cannot be submitted. You can read over that. The submit script will tag your repository. So I don't know if you encountered this in your travels with Git, but Git allows you to basically put a label, a tag they call it, on a particular revision. And this is sort of like marks a point in time, gives you a logical name for like, oh yeah, right, here's like when I submitted. Okay, that's nice. And the reason that it's useful is that you can then use that tag to then make a branch. So hey, let's say that you submit your program and then you get some feedback saying, oh yeah, there was a bug in one of the test cases. You want to go back and fix it, but you've already started the next one. You're an enterprising young person, and yeah, you've already gone ahead. Because the repository was tagged when you submitted a project, you can go back and make a branch off of that. Let's see here. Yeah, by doing something like this. So like here's how you could fix. Oh, that's right. That's yeah, right. So here's where you create the branch off of the tag, and then you can push the branch up to GitHub, and then you can get it locally. But anyway, one of the great things about Git and version control is that you can sort of like go all Back to the Future, parallel universes, all that kind of stuff with your code. Yeah, it can get a little confusing at times, but it also helps you fix bugs more easily. Anyway, so that's available to you in the submit script if you'd like to use it. And so you can say what git push dash dash tags to push that up. Nice. And now if I go look in GitHub, oops, I am looking at GitHub. Duh. If I reload, we'll see that it has, oh, once more with feeling. There we go. It has one tag now, and that it's got, yep, that submit koans on that date right now with that timestamp. Yeah. So anyway, so that's how the submit script works. You'll be doing that once you complete your koans. Any questions about what you've seen so far? Anything new, unfamiliar, anything surprising? No? Okay. Well, we have a little bit of time left. Let's take another 15 minutes and just go through some more koans. Explore stuff together. Give everybody a head start on what they're doing. Are people playing along at home in class? Everything working for you okay? Able to, run stuff, okay? A couple people had a couple of IntelliJ foo-foos and things like that. But, oh, yeah, I guess one important thing that we learned during break. Okay, the koans framework creates this app directory. And in app, there's a data directory that contains parallel files to the koans. So there is like an about, where is it? Like about assertions. Yeah, there's like an about assertions right here. And even though it's ignored in Git, that's why it's grayed out over here, IntelliJ still sees it. So sorry about that. So like one student found that they were editing these files instead, and everything seemed to be working except that there were no changes to Git. And we looked into it. It's like, oh yeah, right. You are editing like this other copy of the classes, not of the source code, not the one that really mattered, not the one that was checked into Git. Luckily, you can just copy the code that he had modified into the real ones. But just beware that, yeah, here in the data directory, there's another copy. That's just the way the koans work. And sorry, it messes things up in IntelliJ, maybe. Just be extra careful. I think I saw something in the chat. No issues, it is working well. Going through the codes, working just like great. Okay, great. Glad things are working. Thanks for validating folks who are on Zoom. Okay, oops. I am editing a file which is ignored. Oh, well, that's nice. So my IntelliJ anyway told me that I was editing a file which is ignored, which I don't want to do. Another tip off, actually, another tip off would be that you don't see the change bars show up in the margin. Okay, now what's next? What's next is about equality. Okay, so I think this is more exploring that. Oh, question? Oh, interesting. So Logan had to update Java past version 17. So 17 didn't work for you, Logan? I thought 17 would, but oh, Java 8. Yeah. Java 8 will not work. But yeah, 17 ought to work for you, and anything beyond 17. And if anyone, is whatever machine they're working on has to use an older version of Java, let me know. Maybe we can work something out. But yeah, hopefully your machine can handle a newer version of Java. Oh, really? Like, yeah, someone's still using Java. Fair enough. Yeah, no, I hear that. That's all it's yeah. There's old stuff, and this thing when things work, it's okay not to fix them until it's not okay. Okay, about equality. So let's see what's going on here. Oh, this is okay. This is some more exploration of the equals equals method and how it works. So, okay, we've got some variables. We have a new object. We have the same object equals that's which is assigned to that object. Now we're going to have assert equals, and that this expression object equals same object. What value should we put here? So yeah, what value should we put there? Yeah, I think that's true. And then let's see here. Does this object variable equals another new object? Correct. It is not equal. Is not the same as. So you can think of equals as the same. So this is very similar to that assert same koan that we did previously. Okay. Oh, interesting, interesting. Okay, so here we're using the dot equals method, and we're using it on instances of Java Lang objects. Okay, so let's see here. Let's look at this first assertion right here. So assert that two things are equal. Object dot equals object. What should that be? Yeah, you're calling equals on the same object. As a matter of fact, IntelliJ is probably complaining about it. Oh yeah, equals is called on itself. It's helping you out again. It's telling you something's a little smelly. So then what should the dot equals method return here in this case? True. Yeah. Okay. Now I have an object that is dot equals to another object. What should that? What would we expect that would return? False. So why do you think it returns false? They are different objects. But I mean, this is something you sort of need to know. But if you look at the implementation of the equals method on Java Lang object, the default implementation of dot equals, because all objects have a dot equals method, the default implementation is just pointer equality, right? It's just are they the same? Because object, it doesn't have much of any state, so it has like very little state associated with it. We'll probably see that other classes behave differently. Oh, like okay, here's one with integer. Actually, just make sure that everything still works. Yep, line 28 now. Okay, this guy. Okay, now line 28 is failing. Okay, here we have now our object is of type integer. So note that you have a variable of type object, but you can assign it an integer object to it because an object is an integer, right? All classes in Java are objects. And now when we call object.equals to object, what should this equal? Yeah, once again, they are the same. And so then one would expect that integer, dot equals would equal to itself. Actually, let's go look at that declaration again. Oops. I'm going to start using keyboard shortcuts because I'm getting lazy. So Command B. Oh, okay. Integer does not override the equals method. Instead, it inherits it from object. Good to know. Actually, is that right? Oh, no. It's not right because, okay. Yeah, this is actually a call to object.equal. But I'm going to navigate into the integer class. And then I'm going to go to method. Symbol? No, I want to navigate. Sorry, I don't even know how to do it here. File structure? No. I know the keyboard shortcut. I don't know the menu item. Option. Oh, not option 12. Okay. Yeah. So if I say command 12, I now get this menu of like here are all the methods in this class, and I want to look for equals. So I type in equals. There it is. Okay, I can hit return. Okay. So here I have the implementation of the equals method on the integer class. Now IntelliJ is telling me that it overrides the equals method declared in Java Lang object, and so it changes its behavior to say the following. So if object is, if the object that's passed in is an instance of integer, then cast it to an integer and invoke the int value method of it, and then return whether or not basically the int value of the other object is the same as my int value. If it's not instance of integer, then return false. So that's how the equals method of the integer class works. Okay, so knowing that, then yeah, we would expect that when two objects, when an integer object is compared to itself, then yes, the equals method returns true. Now, what would we expect then of when we compare this integer object to a new integer object of value 1? What should the equals method return then? True. Now, why does it return true? Right, it's comparing the value of it. And that value there was, I'll go back to that, was there's a field in integer. So now we can navigate by control clicking to that. And yep, so integer has a value field, which is a little I int. You'll learn about the difference between capital I integer and little I int in a little bit later. But oh yeah, look at this. This is where that integer constructor is deprecated, and that's deprecated for removal. That's neat. Okay, cool. Anyway, this is what you do with the components, right? You kind of play with it. You kind of learn about it. And okay, there's some. Oh yeah, there's like a little note there that explains all of this. Okay. Well, let's go a little faster now. So here we have one with, okay, you have two integers. You have an integer of a value of 4 and an integer of 2 plus 2. So are those dot equals to each other? Yeah, so I think those are true. And then the value of value 1 is, what was it looking for here? Yeah, probably value 2. And we could also say 4, I guess. Yeah, did that all work all set? Let's see, I was at 14, now I'm at 16. Yep. Okay. Well, let's see here. Okay, yeah, and this is just showing you that if you send null to the equals method, will a new object ever equal to null? No, so this is false. And then, oh yeah, and then object equal itself, as we've seen before, object equals object is, okay. Yep. Now, it goes a little slow when I'm talking through it and we're doing all the call and response and everything like that, but I think you'll see that, yeah, this goes pretty fast. Okay, about strings. Well, let's do this one. Let me start in on this one. Okay. Look at this one. Okay. Implicit strings. That's an interesting name for it. Okay. Assert equals. Okay. Here I have a string constant, which is a plain old string, and I call get class. Whew, this is an interesting one. It's funny that they start with this one. This is a pretty advanced concept. I'm just going to give you the answer here because it's something that would take some research on your part. And actually, do I still have the reflection lecture in here? I don't think I do anymore. Nope, I don't. Oh, I didn't spell it right either. But reflection, yeah, okay. So one of the more advanced, and actually one of the coolest things about Java is that you have an object and you can get what's called its meta class. You get an object that describes its class. It's kind of, here again, this will make more sense in a couple of weeks once you've had more experience with object-oriented programming. But what you can do is the following. You can say, well, the class for this string instance is string.class. Oops. That passes, right? 18, 19, yeah. So the whole idea here is that there is this, you can get an object that represents, that describes another object, and from it you can like ask, what are your methods, and what fields do you have? And you can invoke the methods and do this all like high-level programming. It's super cool. It's something that we used to talk about in the course a while ago, but it was something that we never really put into practice, so I decided to focus on other things. But it's like a technology that underlies all sorts of stuff like JUnit and a lot of the stuff that we'll see in like the REST API classes, servlets, things like that. But anyway, for right now, you just need to know that if you call get class on a string, it returns string.class. Okay. Okay, here's an opportunity to work with a zero argument constructor for string. My friend's probably complaining, oh yeah, that new string is redundant. So the string is this, the value of empty is this. Do you think string equals empty? Yeah, let's try it and find out, right? Think about it for like a couple of seconds, and if you're curious, try something. You're not going to break anything, right? You're not going to like hurt your computer. Great, it looks like it was. Okay, now new string is redundant. Oh, yeah, yeah. Okay, here we have a string constant here, there, and then we create a new string object and provide it that string. Now, IntelliJ is complaining about it, saying, oh yeah, new string is redundant. So then does that reference to the string constant equal, sorry, does that instance of a string constant equal the reference to it? It does, actually. Right, and here's why it's saying it's kind of redundant. So it's like you don't need to use this. And actually, I've seen like I think I've seen Java code written by students. Well, they'll do stuff where they'll do stuff like this. So you have to. What this is teaching you is that this string constant right here is an object, is a Java lang string object. So you don't need to create another instance. As a matter of fact, is this circuit deprecated? I would kind of hope so. Like I don't even know why they have this. Yeah, I mean, you're right. It seems to me that this is kind of a useless thing. I don't know what intrinsic candidate means. What does that mean? Oh, okay. So this is something where it's like it's an instruction to the JVM to the optimizer or the compiler inside the JVM to like do something fun with it. Okay, neat. Um, okay, so yeah, let's move on. So new string is not identical. Oh, okay, right. So here we go. Now we're creating we're doing that same thing again. We're creating a new string, passing in a constant. And here, uh, yeah, um, here you're saying, oh, do they represent the same instance though? And the answer is no. They are not the same instance. So these two strings are equal, dot equals, but they are not the same instance because you go and create a new object right here. So this is just further reinforcement of what the equals operator does versus the equals method on different types of objects. Oh, int is empty. So the string API, and if you watch the lecture about the Java language APIs, well, it talks all about strings. And string is a class you use all the time, especially in this course. And it's got methods on it, like is empty. So let's just go through these. So is the string double quote, is it empty? Do you think? Yeah, it is. Okay. How about these other ones? The string one, is it empty? Okay, false. A new string, giving it a zero argument constructor. It's empty. Okay, yeah. I agree. How about an empty string? Is that empty? Oh, I can't give it away. And then new string created from one. Yeah, false. Right. So okay, yeah. So here again, some of the Koans, it's like okay, yeah, I got it the first time, but it's meant to reinforce it. Again, you can go pretty fast through them. Uh, let's see here. Oh yeah, string.length. So here's another method on a string, and again, this is sort of like uh, this is driving home the point that when you create a string constant, there's an object there. So string.length. So what's the length of the empty string? Yeah, 0. How about the length of the string 1? O-N-E. 3. Oh, and then this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17. Let's see if that worked. Yep, on 24. Okay. String trim. What do you think string.trim does? Yeah, it takes away white space. How could you could find out by doing a Google search or whatever, by looking at the Java docs online. You can also drill into the implementation of the trim method, and it would tell you what the Java. They can read the documentation right here. So let's see here. Returns a string with a value is whose value is this string with all leading and trailing white space removed, and then it tells you exactly what white space is. Okay, that's cool. So knowing that, let's do this koan. So let's see here. When we take the empty string, we trim it. What do we get? Yeah, it's the empty string because there's not white space there. It's there's like there's no space at all, right? Oh yeah, I guess it already has this one filled in. So when you take the string 1, you get string back 1. One more time with a leading space. What's this going to get? The string one more time. Similarly, you've got some leading and trailing white space. One more time. Oh, what's this backslash t? Excuse me. What's that backslash t mean? It's a tab. Right. It's a tab character, just like in C or C++. And a tab is white space, so when you trim it, it's going to get rid of it. And then same thing here. And it could have used new lines for backslash n or backslash r, backslash n for control, which character for new line, things like that. So let's see here if we got all those right. From 24 to 25. Okay. We got a couple of more. String concatenation. So this is interesting. Before I explain it, what do you think this does? Combines the strings. Yep. Okay, so if we say 1 plus space plus 2, what do you think that equals? Yeah, 1 space 2. So, the thing that you learn here is that the plus operator in Java is overloaded to concatenate two strings together. So the plus operator, the Java compiler, when it looks at the source code, when it parses it and then evaluates it, if it determines that the type of one of the operands to the plus operator is of type string, then it performs string concatenation. Otherwise, if it determines that one of the operands is not a number, is an object of some sort, then it'll perform string concatenation. Otherwise, if both operands for the plus operator are numbers, then it'll perform arithmetic. Then it'll add the two together arithmetically. Yeah. Yes. No, and I say thank goodness. So one of the things that always got me about C++ code is that I'm reading someone else's C++ code and I'm like, wait, what does that mean? It's like, oh, look, they've overloaded the minus operator to print something out to standard out. It's like, okay, I know you can do that, but should you do that? And when the Java language was designed, it was at a time where there was a lot of rebellion against C++, and so they were like, there was not only rebellion against C++, there was a lot of criticism about what C++ was doing in terms of objects. And so things like operator overloading, or rather I would say user-defined operator overloading, so the language, language standard, yep, they override the plus operator, and I think even now that's the only operator that is overloaded. There are lots of operators, but I think that's the only one that's overloaded. So users can't. So people who write Java code can't overload operators, and you can't have multiple inheritance. You have interfaces are so much more powerful than they used to be. So originally, you didn't have multiple inheritance. You can have multiple inheritance of behavior. You can't have multiple inheritance of state. Right, and so you don't have like the diamond problem that we all learned about, right? So they didn't want that. So you can inherit multiple interfaces, and here again you'll see that in the lecture. And interfaces can have constants associated with them. So maybe you can get into the diamond problem with constants. They probably just compile or something. But you don't have like multiple inheritance of instance states. Yeah, no problem. Thanks for asking. So, yep, and so then when we do space 1, 2, we're going to get, space 1, 2. Now notice there's no, right, because we concatenate 1 with 2, there's no space in between it, so we're going to get them next to each other. And then here, I'm pretty sure it's going to be 2 space 1. Let's see if that worked. Yep, or wait, it did, right? Line 80. Yep, and now we're on to this. So anyway, I hope you're getting a feel for what the koans are all about. They are these little short methods that have just a couple of lines that are meant to teach you about one specific aspect of the Java language or of the Java API. As you see going on, you get to see like, hey, what is, there's a method called toUpperCase on a string. You can probably guess what it does, and then you get to apply what it does to test your knowledge. And the same thing with like you learn about compare to, and what compare to does. And what I recommend that you do is play with this code, then also go back and do things like hover over these methods. So there's a method that you don't see. It's like, well, what does compare to do exactly? You hover over in IntelliJ, it'll pop up the Java docs for you. Or of course you can look online too to also see what it does. But what I hope that you get out of the koans is an appreciation for what the Java programming language can do, a general understanding of a lot of the fundamental classes, like strings, and work with arithmetic and exceptions and all that kind of stuff. And then some, there are some more intermediate and advanced things having to do with different like working with dates and regular expressions. You'll see, some of the newer APIs in Java 7, Java 8, all kinds of good stuff. So even though there's a lot of them, I've found that this is a really good way to efficiently get you an introduction to the language that you'll be using throughout the course, and that allows you then to go faster and focus more on the logic of the projects and not the syntax of the language. So while I commit this stuff, are there any questions that you have about what you've seen tonight? Koans or setting things up? There was something here in the chat. Okay. Someone's having problems with IntelliJ not syncing, updating. So ask yourself, are you, Wesley, do you see any changes to your in Git? So if you do a Git status, or if you look in the commit dialog, do you see any changes there? No. Okay, I wonder if you are editing the wrong file then. Because as I was saying before, let me just quick commit and push these. There are two sets of files. So actually, here's what I'd like you to do to test it out. If you go to navigate and you say navigate to class, and you type in about assertions and then go to that, do you see your changes? And again, that was go to the navigate menu and you say navigate to class and then type in the name of the class that you're looking for, like about assertions. Select that, and do you see your changes there? Because by doing that, that ought to navigate to the actual class and not the weirdo copy of the source code over in app data. So no, you don't see your changes. Okay. Do you have the project navigation open on the left? And by the way, that's the end of class. If there are any questions, then we can be done for tonight. And we'll see everybody at 6 o'clock on next Monday. Yeah. Have a good one, everybody. Stay warm and safe.
I think it's my structure.
Oh, wait, what was that, Wesley?
Yeah, I think it's my structure. I'm not sure
okay.
what I'm doing.
Well, cool. I'll stop the recording now, and we can spend a couple of minutes debugging it if you'd like.
Yeah, sure.
Okay. And let me...